Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is set 1 of 5 good problems on the topic of radicals and exponents. I have already completed a few sets of problems on other topics from the chapter of exponents, that is exponential equation, simplifying exponents and comparing exponents. If you have not watched those videos in the same playlist, then please watch them. It will give you a good practice of good problems from the chapter of exponents. So this video is part of the playlist CBS Maths 8 Hot. HOT Hot stands for High Order Thinking, where I come up with relatively harder problems from the topics and chapters as and when they are completed from the other playlist, that is CBSE Maths R.S. Agarwal. If you are new to my channel and if you are not yet subscribed and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 5 good problems of set 1 on the topic of radicals and exponents. Okay, so I have the set of problems, 5 problems. All these are multiple choice questions where one choice will be correct based on the topic of radicals and exponents, that is the radical forms and exponential form of exponents, that is something raised to raised to some power. It is you must always try to solve this problem yourself first. Ideally you should complete the 5 questions in 30 minutes, taking 6 minutes per question. If you are stuck in solving any problem, or if you want to see my method of solution, then please watch this video. It will help you. And please note that I will solve the problems in my way, based on my understanding and knowledge. There are many ways of solving a problem, so you might be having a better way of solving these problems or another way of solving the problems. In any case, please stick to the method that is more understandable and comfortable to you. Okay, so let's start. So now before solving the problems, let me give you a brief about what are the radical forms and what is a radical form and what is an exponential form. So let's say x is a rational number. Let's say x is a rational number, a non-zero rational number, rational number not equals to 0, and let's say m, n, and let's say p are some positive integers. Now a radical form, so I will write some radical form. The same expression or the same value, I will write it as a radical form and in the exponential form, so that it will be easy to compare the two forms. Now first of all, so nth root of x, so let's say, so m and p are positive integers and x is a non-zero rational number. Then this form, which is known as the nth root of x, this is the radical form, nth root of x. Now this value in the exponential form is x to the power 1 by n. Now what exactly is nth root of x or x to the power 1 by n? The value is such that so if we have, the concept is that if we have let's say b to the power n, where b is some non-zero rational number and n is obviously a positive integer. If we have for some b that b to the power n is equal to x, then we say that b is equal to the nth root of x, that is this, or this is in the exponential form is x to the power 1 by n. So this is exactly what it means by the value nth root of x. It will be b, where b to the power n is equal to x. Okay. So this is the basic definition of the radical form. So nth root of x is nothing but x to the power 1 by n. Now let's see some complex forms. Now what will be nth root of this is nth root of x to the power m. Nth root of x to the power m. Here m may not be, I have already written that m and p are positive integers, but in this radical form where we are having nth root of x to the power m, m may not be an integer, it can be a rational number, but n, the root always, in radical form the root will always be a positive integer. So let's say this was 1, this is 2. So the second form, radical form, is nth root of x to the power m. If we want to express this in the exponential form, it will be x to the power m is x to the power m, and this whole raised to the power 1 by n. Now if you further simplify it, this will be x to the power m by n, x to the power m by n. Okay, let's see another form. What will be nth root of mth root of x. So this is the third one, is the radical form is nth root of mth root of x, and this in the exponential form is, first we will so this is nth root of something, that is sum raised to the power n. Now what is that sum? That sum is inside the square root, that is, which is mth root of x, which is x to the power 1 by m. So this becomes x to the power 1 by mn, x to the power 1 by mn. So now x to the power, as you can see, that x to the power 1 by m, that whole raised to the power 1 by n, this can also be written as x to the power 1 by n, and this whole raised to the power 1 by m. So if this is so, then I can say that the radical form mth root of x will be equal to mth root of nth root of x. These two are same, their values are same. Okay. Now few properties also apply in the radical form. For example, nth root of x, where x and y are some non-zero rational numbers, nth root of x multiplied by nth root of y is equal to nth root of xy. And we have similarly nth root of x divided by nth root of y is equal to nth root of x by y. Yes, these are the more or less the standard and important properties of the radical forms and the basic definition of a radical form and its equivalent exponential form. Okay. Now let's start solving the problem. Question number 1. Okay, so it is given that if it is given x to the power y, this whole raised to the power z is equal to x to the power y to the power z, and it is given that y is equal to this is mth root of z, mth root of z, where x and y z are all greater than 1. It is given that x and x y z are all greater than 1. Then m equals, we have to find m. The choices are all in terms of z. So we have to basically find m in terms of z. We have to find m, that is the, so it is given that y is equal to mth root of z. Mth root of z. So it is given that y is equal to mth root of z means z to the power 1 by m. We have to find m in terms of z. Okay. Okay. So let's see what do we get from this equation. We can see that the base is x. In this equation, the base, both the base of LHS and RHS is x. Okay. Now let's see. So we are given x to the power. This is x to the power y, and this whole raised to the power z. And what is the right hand side? The right hand side is x to the power, and the power is y raised to the power z. Okay. Now, if we simplify the LHS, and so that we get a single power, it will be x to the power yz is equal to, we have x to the power y, which is raised to the power z. So now see, in this equation, both the LHS and RHS are in the exponential form, and the base is same, x. So we can equate the powers, and we will have yz is equal to y to the power z. So we get yz is equal to y to the power z. Okay. Now y is also given as mth root of z, which is z to the power 1 by m. Z to the power 1 by m. Now let's see, if I now use in this equation, if I use the value of y as z to the power 1 by m, I get this is z to the power 1 by m. We have this multiplied by z is equal to y is z to the power 1 by m, and this whole raised to the power z. Okay. The LHS is can be further simplified as we have z to the power 1 by m multiplied by z. So this becomes z to the power 1 by m plus 1 is equal to the right hand side. If we simplify, it will be z to the power, the powers will get multiplied, it will be z by m, z by m. So now we get another equation where the base is same, z, and we can now equate the powers. If we equate the powers, clearly we can see we will get a relation between m and z. In the problem, we have to find m in terms of z. So now if we equate the powers, we will get 1 by m plus 1 is equal to z by m. From here we have to solve m. We have to find m in terms of z. So let's bring all the m terms. We see m is in the denominator. If we bring all the m terms to the left hand side, now let's bring all the m terms to the right hand side. We get 1 is equal to z by m minus 1 by m. From here I can take 1 by m as common, and I get 1 by m as common factor, and I get z minus 1. Okay, so this implies if I do now cross multiplication, I get m is equal to z minus 1. So m is equal to z minus 1, and hence the correct choice is D. D is the correct choice. So all these problems are based on the concepts of radical forms and exponential form. Okay, let's do problem number 2. Problem number 2 says that the radical form of, okay, so we have to find the radical form of 6 raised to the power half, and this whole is raised to the power 1 by 3. 1 by 3. Now, so the outer power, is 1 by 3. 1 by 3. So we know that power of 1 by 3 means cube root. So this will be equal to cube root of 6 to the power half. 6 to the power half, because 6 raised to the power half, and this whole was raised to the power 1 by 3. So we know that x raised to the power, where x is some non-zero rational number, x raised to the power 1 by 3 means cube root of x. Cube root of x. So in this problem, x is nothing but 6 raised to the power half. So we have this is equal to cube root of 6 to the power half. Now we have to convert it in the rational form, and you can see that we have to appropriately select the correct choice. Even though our this form, that cube root of 6 raised to the power half, is also in the radical form, but this choice is not there. This form is not there in any of the given choices. We have to appropriately select the correct choice. Okay. Now clearly, how can we further simplify this? Can we further simplify this in a more radical form? We can see that cube root of 6 raised to the power half can also be converted as a 6 raised to the power half I think I could have directly, instead of doing this, since it is asking to convert this into the rational form, what I need is I have to express this entire given exponential form in an exponential form where the power will be something like 1 by m. Then it will be a cube root of m. Now where m has to be a positive integer. Now I can see, applying the laws of exponents, this will be equal to 6 raised to the power half multiplied by 1 by 3, which is equal to 6 raised to the power 1 by 6. And clearly we see that the power 1 by 6 is in the form 1 by m, where m is 6 and 6 is definitely a positive integer. So this will be clearly 6th root of 6. 6 to the power 1 by 6 is nothing but 6th root of 6. So D is the correct choice. D is the correct choice. I am wondering, I can see that choice C is also the same thing. Oh, so why? Okay, so one thing to note is that it has asked to express 6 to the power half whole raised to the power 1 by 3 in the radical form. Please note that the choice C, the expression of choice C is not in radical form. This is not in the radical form, because this is an exponential form, because we are seeing something raised to the power 1 by 2. Even though that something is in radical form, that is cube root of 6, that this is the base, but this whole thing is in exponential form because it is something raised to the power half. So even though cube root of 6 whole raised to the power half is equal to the given expression, that is 6 raised to the power half and whole raised to the power 3, 1 by 3, but choice C is not in the radical form. Choice A, B and D are in radical forms. So the correct choice is D. Okay, let's do problem number 3. Okay, so one equation is given. Then the value of, we are asked to find the value of n by square root of pq. Okay, let's see what is given. It is given a by b. This is the base. This is raised to the power 1 by p minus q, and again this whole is raised to the power of square root of p minus square root of q. Okay. If so, this is the equation is given that this is equal to nth root of a by b. Nth root of a by b. This is given, and we have to find what is the value of n by square root of p q. We have to find this, the value of this expression, and we can see all the choices are in terms of p and q. Okay. Now let's simplify the left hand side of the given equation. We have to somehow find n in terms of p and q. Okay, so the right hand side is nth root of a by b. So we have to somehow express the left hand side of the given equation as some root of a by b. Some root of a by b. That is, we have to express the LHS as the power of a by b, base is a by b, raised to the power and the power will be in the form 1 by m. Okay. Okay. So if we simplify the LHS, the powers will get multiplied, and we get the LHS is equal to a by b whole raised to the power square root of p minus square root of q divided by p minus q. So this is equal to nth root of a by b. Okay. Now nth root of a by b is nothing but a by b whole raised to the power 1 by n. Okay. Now the power you can see on the left hand side, the power is root p minus root q whole divided by p minus q. Now we can simplify the power because the denominator of the power p minus q can be expressed as a square minus b square. Okay. So a by b we are having raised to the power p root square root of p minus square root of q divided by so p minus q can be expressed as p. We know p can be written as square root of p square of square root of p. This is equal to p, and also similarly q can be written as square root of q. Please note that x is equal to square root of x and this whole raised to the power 2, or this is also is equal to square root of x square. Okay, so we have this p minus q can be written as square root of p minus square root of q. So we are having an algebraic expression in the form a square minus b square, and we know using algebraic identity a square minus b square is equal to a minus b multiplied by a plus b. This becomes square root of p minus square root of q multiplied by square root of p plus square root of q. So the denominator of the power of the LHS can be written as square root of p minus square root of q multiplied by square root of p plus square root of q. So we can cancel out square root of p minus square root of q from both denominator and the numerator of the power, and on the right hand side we have a by b raised to the power 1 by n. So after simplification the LHS becomes a by b whole raised to the power 1 by square root of p plus square root of q is equal to, we are having a by b whole raised to the power 1 by n. Now we see in this equation both the base are same, a by b, so we can equate the powers and we get 1 by square root of p plus square root of q is equal to 1 by n. So this implies that the reciprocal, if a is equal to b, if we know that if a is equal to b, and definitely for non-zero numbers a and b, if a is equal to b, this will imply that 1 by a will be equal to 1 by b. So we will have square root of p plus square root of q will be equal to n. So n is equal to square root of p plus square root of q. So this implies we have to find the value of n by square root of pq. So we have n by square root of pq becomes n is square root of p plus square root of q, and this whole divided by square root of pq. This after simplification will be 1 by square root of q plus 1 by square root of p. So the correct choice is D. D is the correct choice. Okay, let's do problem number 4. Problem number 4, it says that x plus y plus z is equal to 3. Then the value of cube root of 2 to the power x multiplied by 6th root of 4 to the power y multiplied by 9th root of 8 to the power z. We have to find the value of the given expression, which is a product of 3 radical terms. Okay, so we are given this fact that x plus y plus z equals to 3. Now let's see what is cube root of 2 to the power x multiplied by 6th root of 4 to the power y multiplied by 9th root of 8 to the power z. Now if we further simplify, if we convert all the radical terms, radical factors into the exponential form, then we will get, so the first one is cube root of 2 to the power x, which means 2 to the power x raised to the power 1 by 3. This multiplied by, we have 6th root of 4 to the power y, which means 4 to the power y, this whole raised to the power 1 by 6. We have multiplied by 9th root of 8 to the power z, which means 8 to the power z, this whole raised to the power 1 by 9. Okay. So this is equal to, now applying the laws of exponents, this will be, the first factor will be 2 to the power x by 3, 2 to the power x by 3 multiplied by, let's convert the 4 and 8 as a power of 2. So 4 will be 2 square, and we have raised to the power y, and again raised to the power 1 by 6 multiplied by, let's convert 8 as a power of 3 as a power of 2. So it will be 2 cube raised to the power z, and this whole raised to the power 1 by 9. Okay, so this becomes 2 raised to the power x by 3 multiplied by, we have 2 square raised to the power y. So this is 2 raised to the power 2y, and this whole raised to the power 1 by 6 multiplied by, similarly we will have 2 raised to the power 3z, this whole raised to the power 1 by 9. Again applying the laws of exponents, that is a power of a power, we get The second factor will become 2 to the power 2y by 6 multiplied by, the third factor will be 2 to the power 3z by 9, 3z by 9. This is equal to 2 to the power x by 3 multiplied by 2 to the power, if we simplify the power, 2y by 3, 2y by 6, it becomes y by 3, and multiplied by, if we simplify the power 3 z by 9, it becomes z by 3, z by 3. So now we see three factors where three factors are in the exponential form where the basis is 2. So we will merge them to a single exponential form by adding up the powers, and we have 2 to the power x by 3 plus y by 3 plus z by 3. This is equal to 2 to the power, if we simplify the power, x plus y plus z divided by 3. Now x plus y plus z is given to be equal to 3. So this becomes 2 to the power 3 by 3, which is equal to 2. So the correct choice is A. A is the correct choice. Now please note, if I am incorrectly solving any problem, or if I am applying any incorrect concept, then please feel free to let me know in the comment section. I will highly appreciate that. And if you have any question or doubt in any kind of discussion or concept that I am applying in solving the problem, then also please do let me know. Okay. Let's solve the last problem, that is question number 5. Exponential form of we have to find, we are given a radical form, we have to find its exponential form. Okay, so what is given, we see there is an mth root, this is mth root of, and that of is, this is square root. Okay, and inside the square root we have nth root of x to the power p. Okay, so let's try to simplify this radical form from inside to outside. That is, let's simplify the expressions from expressions inside the innermost square roots, not innermost roots, that is this symbol roots, moving simplifying outwards. So x to the power, the expression in the innermost root, the expression or value inside the innermost root is x to the power p. That is fine. Now what is, let's try to simplify, or let's try to convert this expression in the exponential form. So this becomes mth root of, we have a square root, and then we are inside the square root, we are converting the radical form, that is the nth root, to the exponential form, and it will be x to the power p, this whole raised to the power 1 by n. Okay, now let's convert. So we have mth root of, and that of is square root of x to the power p whole raised to the power 1 by n. Now okay, now so this will be so this is equal to, if I simplify this part, that is applying the laws of exponents, it will be we have this, and inside the square root it will be x to the power p by n, because the power p and the power 1 by n will get multiplied. We have this. Now let's now convert So we have a radical term inside another radical term. The outside radical root is mth root of, and that of is square root of x to the power p by n. So let's convert. So this is the radical term. Let's convert this radical term or radical expression as exponential form. So this will be, so we are working from inside to outside. Mth root of, it will be square root means power half. So it will be x to the power p by n, this whole raised to the power half. Raised to the power half. As we know, square root of any non-zero rational number x is equal to x to the power half. Okay. So now we have this is mth root of, we have something inside. So this will be whatever we have in. Okay, now further simplify. Let's simplify this exponential term by using the laws of exponents. So this becomes, we have mth root of, the power will get multiplied, and this will be x raised to the power p by twice n. So now the final step will be, we have mth root of something, and so in the exponential form it will be that something which is x to the power p by twice n, this whole raised to the power 1 by m. And this again, applying laws of exponents, will be the powers will get multiplied, and we have x to the power p by 2m n. And hence the correct choice is D. D is the correct choice. Okay, so this brings to an end in solving 5 good problems on the concepts of radicals and exponential form and exponents. That is radicals and exponents. That is expressing an exponential a number in the exponential form into a radical form, and vice versa. I will, if possible, I will make more sets of 5 good problems on the same topic of radicals and exponents, because this is a very crucial thing to understand in solving problems on exponents. I hope this video will be beneficial to you in understanding the concepts of radicals and exponents and how I am applying the concepts to solve some good problems. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. Keep an eye on this playlist, as I will be coming up with more sets of 5 good problems on various topics from the chapter of exponents. So some important topics left are prime factorization and some word problems, and conversion of numbers in standard form and scientific form. So all these videos of 5 good problems on these topics will be coming soon. So please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.